everybody, welcome back to another Ms. Pollard Math YouTube video. Today we're going to be doing one of our geometry topics, which is also a trigonometry topic, which is law of cosines. This topic is a little tricky in the sense it has a long equation. You have to figure out if we're losing law of cosines, law of sines. So it becomes tricky in the sense of what are we looking for, what are we applying, how are we going to solve this. So first I think it's important to go over what law of sines is so we know the difference between which one we're going to be using. So the law of sines is an equation where we are trying to solve triangles. So when I say solve triangles, we're trying to find the angles, we're trying to find the side lengths, but these are not right triangles. Usually we use SOHCAHTOA for right triangles, but now this is for our triangles that are acute, that are obtuse, that do not have a right triangle. So this works, law of sines, works when we have an angle and a side, or an angle side angle, or two sides and the angle opposite of one of the two sides. So that would be side, side, angle. These are similar because we've been working with congruence. So we have an angle, angle, side. We have an angle, side, angle. So that's a way to remember it. The only one difference here is we do not have side, side, angle congruence. So we just have to think, oh, it's the one that is not normal for us. That's going to be for law of sines, where that just says we take the sine of angle A. So capital means angle, lowercase means our side across from that angle. So sine A is going to be angle A, and across from it is side A, which is lowercase a. So we're going to take the sine of A divided by A equals the sine of angle B divided by side B, and that also equals the sine of angle C divided by side C. And usually we only use two of them, and we'll create a proportion and cross multiply. But this video is about cosine, and I will show you how to use the law of sines, but we're more focusing on the law of cosines. So if it's not one of these three options, we have to use the law of cosines. I like to think more so, though, of which ones work on law of cosines, and if they don't work for that one, we're going to use the law of sines. So let's take a look at what even law of cosines means. So the law of cosines is solving triangles when we have side, angle, side, or side, side, side. The important part here is side, angle, side. It has to be that included angle. It has to be a side with the angle in the middle with the side. So what I like to think about, if it's not side, angle, side, it's not side, 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 I have to use my law of sines. But these work for my law of cosines, where it's saying that I'm taking my side squared, equaling it to the other two sides squared added together, minus 2 times those opposite two sides, times the cosine of the angle. So I know that sounds like a lot, and there's 3 long equations, but really if you just memorize one, you're able to continue with all of them. So I'm just going to memorize one, where I take my side and I take my angle across from that side, and they're going to be the sandwich. So they're going to be on the outside. Then on the inside, we're taking the other two sides, squaring them, adding them together, minus 2 times the other two sides, times the cosine of the angle in which we're trying to find the side, or we might be trying to find the angle, so I'm going to be looking for my side. So there's going to be a lot that we're trying to do here. We're either looking for our side, we're looking for our angle. No matter what, we're going to sandwich the angle and the side, whatever one we're looking for, they're going to be on the outside of the two to be able to continue. So I know this is a lot of words, but let's look at one of the challenging ones that we might be seeing. So I look at this problem, and I have 3 side lengths. So this is going to be side, side, side. So when I have side, 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 I'm going to use my law of cosines. So my law of cosines, I'm going to find angle A first. So I'm going to say this is x just for our purposes. So that's what I'm looking for now. So I'm going to take my opposite side, square it. So it's 13 squared, equals my other two sides squared added together. So I'm going to do the 17 squared plus 15 squared minus 2 times the other two sides, which I'm going to just stick with the order, 17 times 15 times the cosine of A. And I'm looking for A. I'm looking for that angle, so I can't plug anything in because I don't know what that is. So now I'm going to put in my calculator, 13 squared, and I get the 169 equals 17 squared, which is 289, plus 15 squared, which is 225. Now, I can't combine that with the negative 2 times 17 times 15, because this is a variable. This is something we're looking for. So we can't just combine them because they're not like terms. They don't both have the cosine of A. So I'm going to do negative 2 times 17 times 15, and I get negative 510. So it's going to be minus 510 cosine of A. Now I can combine these. I do 289 plus 225, and I get 514. I'm going to subtract that over because these are the like terms that we're trying to solve A. We're trying to isolate the cosine of A, get it by itself. So I'm going to subtract 514 because that was these two added together. That cancels out with this. So I get 169 minus 514, which gives me negative 345, equaling negative 510 cosine of A. I divide by negative 510, and I get 345 divided by 510 equals the cosine of A. Some teachers might make you simplify. Those are big numbers. I don't personally care because I know simplified or not, that's going to give you the same answer. To get the A by itself, you have to use the inverse cosine. Anytime you're trying to find an angle, you use the inverse cosine. So I'm going to do the inverse cosine of this. That cancels out then. Make sure your calculator is in degree mode. A lot of them, standard calculators or graphing calculators, will put it in radian mode. So you have to go to mode, go to degree to make sure we get the right answer. So I'm going to put inverse cosine of 345 divided by 510. And I get my A as approximately, because it's not exact, I like to round to one decimal place, 47.4 degrees. Now I'm going to continue using the law of cosines just so we can get used to working with it. However, at this point, because we have a side-side angle, we could use the law of sines. But what if we messed up somewhere? What if this is actually supposed to be 54, something like that? So that's why I like to just stick with the law of cosines just in case I made an error somewhere. So I'm going to do the same process now. So if you need this information, pause it, write it down, do what you have to do. I'm going to erase this, and I'm going to find one of the other angles. So now I'm going to try to find angle B. Across from angle B is 17. So I'm going to do 17 squared equals, take the other two angles, square them, minus 2 times those two sides, times the cosine of B. So I get 17 squared, which we saw was 289. Equals 169 plus 225, which we know that from our prior work, minus, I do 2 times 13 times 15, which is 390, cosine of B. I'm going to combine these, 169 plus 225, and subtract that over, which is 394. So I do 289 minus 394, which is negative 105. I divide by 390, and I'm going to inverse cosine that. So I'm going to inverse cosine the 105 divided by 390, and that's going to be my angle B. So inverse cosine 105 divided by 390, and I get angle B is approximately 74.4 degrees. Now at this point, what we could do is just do 180 minus 74.4 minus 47.4. And this should be, if we did our math right, 58.2. Well, once again, that was the key point. If we did our math right, there are so many places that we can error here, that we can get something wrong. So once again, I'm going to double check using the law of cosines to make sure everything plays out. So once again, if you need this, pause it. So for the last time, I'm going to take the opposite side, which is 15 squared equals our 17 squared plus our 13 squared minus 2 times our 17 times our 13 times the cosine of our C, which is what we're looking for. I get 225 equals 289 plus 169 minus 2 times 17 times 13, which is 442, cosine of C. Then what I'm going to do is 289 plus 169, And I get 458, which I'm going to move over. So I get 225 minus 458, and I get negative 233 equals negative 442 cosine of C. I'm going to use the inverse cosine, divide this over, take the inverse cosine. So the inverse cosine of 233 divided by 442 equals my angle C. Put it in my calculator, and I get C as approximately 58.2 degrees, which is what I wanted. So as you can see, I did my math right, which is great, seeing I'm the math teacher, but I'm going to always double check, because what if I got here 55 point something? That clearly doesn't add up to 180. I did something wrong. I can check where I did. Another thing that we have to know is if we're looking for the side length, let's say I did not know the side, I am going to put this as C squared. I would put all this into my calculator. If I knew the cosine of C was 58.2, I would do 17 squared plus 13 squared minus 2 times 17 times 13 times the cosine of 58.2. And then I would square root it, and that would give me the 15. And I can double check my work. So let's see. Let me show you that so you can see how we would complete that. So I just found that my cosine of C was 58.2 is my C by doing that. And I'm trying to find this now. I know obviously we have it, but I just want to be able to show you if we're looking for a side length. So this is going to be my C squared. So that's going to be my side. So my C squared equals 289 plus 169 minus, I'm going to do 2 times 17 times 13 times the cosine of 58.2, which gives me approximately 232.914 ... I'll keep it all in my calculator when I calculate it. So 289 plus 169 minus that 232.9 blah, blah, blah. And then I get C squared equals 225.0 ... And I square root that. And I get C is approximately 15, which is exactly what I wanted. So I know that they gave you the 15 already, but I wanted to show you that if you were looking for a side length, that's how you would do it. Personally, I think the hardest part is finding the angle, so that's why I showed you a whole problem finding the angles, but I want to show you if our C is what we're looking for, one of our side lengths we're looking for, that's how you complete it. So now I'm going to act like, which you already saw, that I did the cosine law of cosine to find my angle A. And now I'm going to apply the law of sines. And once again, this is very important that we're only applying the law of sines if we're 100% sure with our angle. Of course, I know I'm 100% sure. I did all the measurements. I did it correctly. But if we're not 100% sure, I would stick with using the law of cosines, because if we got this number wrong, then these two are going to be wrong as well, because the law of sines would be incorrect. A way we could see if we're incorrect is when we use the law of sines, if we add the 3 up, it might not give us 180 degrees. It might be a little bit funky. So I like to stick with, if I'm using the law of cosines, stay with the law of cosines to make sure everything is proper. However, if you want to take that shortcut and you are adamant that you are correct, you can use the law of sines. So the law of sines you can use when you have a side, and an angle, which we just figured out that we have. So the law of sines tells me I take the sine of the angle and divide it by the opposite side to it, which is little a, which is 13. And I'm going to set it equal. I'm going to find angle B. So the sine of B and its opposite side is 17. Now I'm going to do 17 times the sine of 47.4 equals 13 times the sine of B. I multiply these two together. I want to get the B by itself. I want to get the sine of B by itself, but more specifically, angle B by itself. So I'm going to divide by 13. And then to get the sine alone, gone, bye-bye, I'm going to inverse sine it. So that gets rid of the 13. It gets rid of the sine and just leaves me with the B. So if I put in my calculator I would do sine of 47.4, enter, times 17, enter, divided by 13, enter, and then I'm going to inverse sine that number. And when I inverse sine that number, I get my b as approximately 74.4 degrees, which we just saw. Now I'm going to do this again to find my angle C. Once again, I could do 180 minus 74.4 minus 47.4, and I get that 58.2, or I can just find the sine again, just in case I made an accident. What if that was 74.9? It would be a little bit off. So I'm going to do, once again, the sine of 47.4 divided by its side across from it, which is 13, equals the sine of C, because now I'm trying to find angle C. Its side, its little c across from it, is 15. I'm going to put in my calculator 15 times the sine of 47.4 equals the 13 sine of C. I divide by 13 to get rid of that 13. I inverse sine it to get rid of the sine. Put that right here. And that leaves me with C is approximately, so I do sine of 47.4 times 15 divided by 13. Inverse sine that, and I get C is approximately 58.2 degrees, which is exactly what I wanted. We saw before. So I just wanted to show you both ways of how to use the law of cosines, because that's so important to make sure we're accurately completing the problem, and how if you have trust in yourself, you could then use the law of sines because you are positive that that's the angle to apply. Once again, I'm a little weary of doing that, but I wanted to show you the ways just in case you want to take that risky avenue. So I hope this was helpful to see how to apply the law of sines, but also more importantly, the law of cosines.